And hello, everyone. My name is Hakeem Mohammed, and I'm from the Atlanta area, as you can tell by the accent. I'm just kidding. So I primarily work on the cloud using Azure, but I also deal a lot on the data science, big data, machine learning kind of things. So dabble a lot, and been kind of tinkering with Hadoop for a while now. So that's what I'm going to talk about, and at the end, dig into the project that I started that Glenn alluded to. So I hope everyone is excited. I don't know if it's a good time to give a talk before lunch when everybody is hungry, or after lunch when everybody is about to doze off, but I hope I can keep it interesting. So what is Hadoop? It's primarily a data processing framework. Like these days, people are referring to it as an operating system as well for processing large quantities of data. Started life back in 2006. Actually, this was started by a bunch of guys at Yahoo based on a paper that Google created or Google produced. Called Big Table, yeah. So based on that, so the guys at Yahoo, they were looking for ways to optimize their search engine, and Google just published a paper using the MapReduce pattern, and they took off it, and then that's how this project got started. So it could mean different things depending on the context or who you talk to, right? Or like if you're talking to a vendor, or if you're talking to people who work on Hadoop, because Hadoop, if you look at the core Hadoop, it's just like the HDFS, which is a distributed file system, and the Yarn, which is the resource management and the processing platform. So that could be Hadoop, but it could be the whole ecosystem. Again, depending on the context. So Hadoop ecosystem, it could be overwhelming or intimidating, if you just look at it, because there's so many pieces to it. There's Scoop for if you want to pull data from a relational database. There's Flume, there's Hive, there's Pig, there's Impala. But I mean, it's not so complicated as it looks to be. Once you start peeling through the layers, it is pretty simple, and we'll dig through some of those in the time that I have today. So it's entirely written in Java. So the whole framework, it does have some native code though, a little bit of C, C++, primarily for interfacing, but it's all Java based. Primarily, it started life as a MapReduce framework. People who've been dealing with F#, it comes natively for them, what MapReduce is, because F# has some native code. And we saw some of it yesterday and even today too, during the F# talks. So that's what Hadoop started as, primarily a framework for MapReduce. But then it's evolved. Now there's this whole Yarn technology that actually is could be used to, I don't know how many people were there in Karthik's talk yesterday on Spark, and he was talking about it Spark running on clusters. So Spark technically runs on Yarn too, and Yarn could be used for graph processing frameworks like Giraffe. There's this Impala from one of the Hadoop vendors, and there's a whole bunch of things that Yarn could support. So that's Hadoop in a nutshell, or maybe in a peapod, because there's so much to it. So moving on. So what's the design behind Hadoop? So Hadoop, it's different from traditional frameworks where we pull data, right, to an application server, and then we work on the data, and then we push it back. That's usually what we do with typical CRUD applications, right? Data is sitting in a database, we fetch it, we do some processing, and push it to a user interface, or store it back. Hadoop changes it completely in the sense that we are not fetching data to the code, we are pushing code to the data. And the reason behind this is like there's no latency, right? You're not spending all your time. If you think about it, Hadoop was created for like processing like huge amounts of data. So if you're thinking about like pulling all that amount of data onto your app server, it's going to die. So instead, Hadoop takes the opposite approach and then pushes code to the data. And obviously, since it supports like huge, data of like huge volumes, there has to be a distributed file system. And the default one that comes with Hadoop is called HDFS, Hadoop Distributed File System. And then it also has the yarn cluster that I will cover both those in a bit. So when you want Hadoop to process data, like you just load it in into HDFS, like so your data sources could be anything, like could be a Twitter stream, like could be a SQL database, could be log files, structured or unstructured. Any kind of data you can pull and store it into HDFS. So think of it as a distributed file system. I mean, there's no structure to it. You can store any kind of data you want. And then once Hadoop processes the data, right, you can store it back into HDFS, or it could be written back into like any other databases, like Cassandra, for example, or even any relational databases too. And then the applications for Hadoop, like you could technically write in any language. Example, MapReduce. You could write it in Java, or Hadoop has this concept called streaming. What you could do with streaming is, and I'm going to show some code snippets in a bit, you could write it like for example, in F#, C#, Python, anything, and using Hadoop's streaming feature, you could send it to the Hadoop cluster, and then it processes the data, like using your maps and your mappers and your reducers, and then puts it back wherever you want it to. So what we are going to do is like we are going to dig a little bit deeper into like the HDFS design. So HDFS is designed for storing very large files, like could be terabytes, petabytes, maybe more. And it's usually running on clusters. Like it's not just like one or two servers. It's like thousands of clusters, node clusters, which like made up of cheap commodity hardware. So the design or the pattern that HDFS uses is like you write it once, but you would be reading it over and over. So it's what's called a warm pattern, like write once, read many times. So HDFS is really good for that. So what happens is when you push data to HDFS, it's stripped out. It uses a technique called striping and mirroring. Striping is where your data is chopped up into blocks. And mirroring is the blocks are replicated across the cluster. So that's what HDFS does. So, and the way it does is it has a name node which has the metadata for the blocks that you're storing, like which block is stored where. And then lots of data nodes, and these could be like in the thousands. That's where your blocks are stored. So the name node has the details of which block is where. So when a client, when it sends data to HDFS or wants to read data from HDFS, it's going through the data node first. So that's the first point of call. And then there's like different ways of interacting with HDFS. There's like command line interface. These are like Linux-based commands like ls or put, get, or there's a RESTful API too if you want to use it. Or there's a Java SDK as well for interacting with HDFS. And then lastly, it's not a good fit for some kinds of applications. For example, like if you want like low latency data access, or if you have too many small files to write out to, then HDFS is not a good fit. Or like multiple writers too, because like it again is like a write once, read many times pattern. So So those are some cases where HDFS is not a good fit. And then this is the flow for like what happens when you're writing data to HDFS. So HDFS client, it could be like a console application, or it could be like a RESTful application. So you call the HDFS service running, which is a daemon. What it does in turn is like it contacts the name node, like saying, hey, I have data that needs to be written. The name node gives you the pipeline of the data nodes that like could be used. So think of the pipeline as a linked list of data nodes. So it could be like, as I have here, like typical replication factor, by the way, is 3. And the block size is 128 MB. So what the name node does is like, here you go. Like I could have like data nodes A, B, C, or D, E, F, or whatever. Says like, this is your pipeline. Go write your data. And then like it only sends the first one first. Like so, you only talk to the name node once. So it sends the head of the pipeline. And then, so the client is interacting only with the first one. So, and the first one knows the details of the other two that are following it. So think of it as a linked list. So that's how data gets written out to HDFS. And then a read is similar. Again, like a client contacts the HDFS daemon, asking for data to be written, and the request goes to a name node, and the name node knows, like, it has the metadata, like where the data is, like where the blocks are distributed, like what the replication was, and it sends the address of the blocks, and based on that, the data input stream, that's the core class in here, that actually reads the data back from the data nodes. So, and then there's a lot of redundancy built into this. So the name node is keeping track of like the health of the data nodes. So the data nodes are sending back heartbeat monitors back to the name node, like saying, hey, am I alive? So that's how the name node is keeping tabs on how well the system is working. So if the name node like detects that a data node hasn't sent a heartbeat like in a set interval, then it figures out, okay, it must be dead. So what it does is it marks the data node as dead, and based on the replication factor, let's say I have a replication factor of 3, and then the name node didn't receive a heartbeat from the second name node. What it does is it marks that data node as dead, and like it creates another data node for it, and then it replicates that block on the new node. So I mean, it could have been better with PowerPoint animation, but my animation skills are not as good as my coding skills. So just you have to put up with my hand waving. So that's how HDFS is accomplishing high availability of the data in the cluster. The other core component in Hadoop is what's called yarn. Yarn stands for yet another resource negotiator. So what yarn is doing is it has like two prime components. Like again, it has a resource manager, which is like one per cluster. This is similar to the name node in HDFS. So this like is handling all the requests for the resources in the cluster. And then there's like a ton of node managers, right? So these could be the same range as like you have the number of data nodes. So this is where the action happens when you run a Hadoop job. And what the name nodes do is like they have containers. When we say container in this context, it's not the same as a Docker container. So these are like containers, like think of it like as a address space, a JVM address space for running your code. So that's what a node manager creates, and it runs the map reduce or any code that it was given. So typically, like in a Hadoop installation, the resource manager and name node are co-located. They are only one per cluster. Although with the name node, like so the name node, it could be like if we go back, there's only one per cluster, so it could be a single point of failure. So what Hadoop uses is a concept of high availability, where like you have a secondary name node, and that's where you get into things like journaling and all. So you have to have it as a hot backup where the secondary name node like is aware of like everything that the primary name node has, but then you can't have two name nodes. So it would use some kind of a journal maintainer like Zookeeper or something here. So going back to Yarn, so resource manager and name node could be on the same machine technically, or you could separate them out, but they have to be really beefy machines because they have knowledge of the entire cluster in terms of data and processing. And then the node managers, they typically run on the same machines as where the data nodes are. So this is like a high-level data flow for a Yarn resource. So you have the resource manager, which is only one per cluster. So when we start a Hadoop job, what the resource manager is doing is like it's contacting like the first available node manager that it knows of and says, hey, this is a job like that I want you to run. So the node manager then it could do like it will launch its own container, but then if it thinks that it needs more resources, it's going to talk back to the resource manager saying, hey, I need more resources. So the resource manager again is similar to a name node, so it has knowledge of all the node managers in the cluster. So like who is available, who is idling, or who has died. And so based on that, like it allocates resources. So and all these node managers again are sending heartbeats back to the resource manager, saying, "Hey, am I alive?" So the resource manager can keep track of like whether it needs to bring up new nodes or it can just let it be. Most of the communication here, it's like it's happening. It's not HTTP. It's Hadoop RPC. There's a lot of RPC code like in Hadoop. So that's how the communication is going on between the node and the resource manager and the nodes. So we'll just quickly jump to a demo here. So what I'm going to do is I'll just show you guys like some of the stuff that I talked about. So so this is the HDFS config. Oh, okay. All right. So this is the configuration file for HDFS. So the first one there is the replication factor. Since I was running locally, I mean, it's just one machine. I set it to 1, but a typical replication for the data is 3. And then like I got the locations for where the name node is. SNN is for the secondary name node, and the DN is for the data node. So I'm specifying the locations for the name node and the data nodes. And then similarly, like there is a map-read file. So this is the configuration for the MapReduce framework. So with the after Hadoop 2.0, the emphasis has been primarily on Yarn. So you don't see a lot of like going forward, like a lot of action going on the MapReduce side. But this is the very first entry is what is important here. So what I did was I specified for the MapReduce framework, I said use Yarn. This was different in previous versions of Hadoop. And then like in the Yarn side, like there's some settings that I had to do. Since I was running it on Windows, I have to specify the class paths for where the jar files are. And also the shuffle handler class where to use, like, because MapReduce uses a concept called shuffling, where when data is sent from the mapper to the reducer. And then the resource manager address, I'll show it in a bit. Like, so this, since I'm running it locally, I specify it as my local host at port 8080, but this could be different if you're running it on a cluster. So what I'm going to do here is just quickly run these. So what I'll do is, like, I'll just create the so this is the path I specified for in my HDFS site, where I said I'm going to have my data nodes and the name nodes. So I'll just create a data node folder here and a name node folder here. Right. Okay. And then what I'm going to do is I'll just format them so that they're all clean and ready. So name node. So just formats the name node. I'll do the same thing for the data node. Oh, not dim. Okay. So now what I'm going to do here is, like, this is, I got like a bunch of daemons here. Like when you build Hadoop, or when you get a Hadoop VM. Well, if you get a Hadoop VM, the daemons are already running. But if you're running your own Hadoop installation, like, you have to start your HDFS and Yarn services. So the SBin folder is where you have all the daemons that you need to start before you can do anything meaningful with Hadoop. So first off, I'm going to start the HDFS service. So here, it launched me the data node and the name node. So if I ask for the processes that are running here, I see I got a data node and a name node here. Right. So the next thing I'm going to do is start the Yarn service. And I got Yarn running. Okay. So if I go back, say, yeah. So I got a data node, I got a name node, and I got a resource manager and a node manager. So I got, like, Hadoop running on my machine now. So what can we do? Like, we can do a lot of cool things here, right? So for example, so I want to, let's see, I want to. Let me go back to, so I got some data here. So I got this iris data set .txt, which is like if you start if you're into machine learning, like, that's one of the things that you would get started with. Like, usually it's like a few types of data. So based on that, like, it's your typical classification example, right? Like, where based on certain characteristics, you classify it as a whether it's what kind of tree it is or plant it is. So that's the data set. So let's say if I want to put it in Hadoop, like, I get started with HDFS, say HDFS, DFS, and then it takes, like, the standard Linux command. So I'm going to query for the root folder to see what I have there. So, and I don't have anything there. So I could create, like, a folder here. And then it created a folder for me. So if I query it again, I see that folder there. So if I want to check all these services here, so what I do is, Oh, I got a 5-minute warning. So what I'm going to do is, I guess I'll skip the demo and I'll do another session, like if folks are interested. Real quick, you could go to the admin dashboard here. This is it shows the health of your data nodes and the name nodes, and then you could also check the status of your jobs. If you remember in the yarn cluster, I gave my address as 8088 localhost. So this is where it shows like all the status of my Hadoop applications that I have, like I ran in the past or running or killed or whatever. But if you go with traditional Hadoop vendors, they got slicker tools. All right, so I guess I'm going to skip my demo here because I only got 4 minutes. Can you say it again? If I want to do jobs like .NET. Yeah, that's where you do streaming. Streaming is one option, and I believe Microsoft also has like a Hadoop MapReduce extension. I don't know if it's still active or not. I saw that project back on Codeplex. It was, I think, quite a bit ago. No, so and that's what like I just wanted to cover. So why am I talking about all this? Like talking about Java and all. Like so let's say yeah, that's the question that Glenn hit. Like you don't want to install Java, right? Like I don't want JVM on my machine. So but I still want to have the goodness of Hadoop. So what am I going to do? And that's the reason of my talk here, because I mean, what's the point of talking about a Java framework at the .NET conference? So here, I started like on a project, like looking at it, like so what if I'm a .NET shop and I don't have Java people, I don't have the JVM expertise. I mean, what are we going to do, right? So that's where this got started. So this is the project that I want to talk about. So if you look at it, so I just started the project as Glenn was talking about it. Like I was working on it. I'm still the only guy. So if you look here, so and and this is where like this is the core theme of my talk here. So this project is underway to have a .NET version of Hadoop, like have Hadoop on .NET using C# or F# for that matter. I don't want to install Java. I don't have to pull in guys who know Java, right? So here. So this is my project here, Hadoop.NET. It is a .NET port of Java, completely in C#. The thing is, it's just getting started, so there's a lot of work to be done here. And this is where, like, if I go back, how much time do I have? Skip. So I couldn't have made it bigger and bolder. You're all Uber geeks. I guess that's the reason you're all here. I mean, this would be something really cool and something really big and challenging to work on. And this is where, like, I mean, if I continue working by myself, I guess it'll be done by the time Elon Musk puts a man on Mars. So this is where, like, this is my contact details, and I'm going to put my slides up too for this conference. But, like, please get in touch with me. I'm looking for contributors to help out. This is like a humongous project, and something which is like, I wouldn't even have started it if .NET Core wasn't announced and the promise of XPlat was not there, because like very few enterprises run Hadoop on Windows. It's primarily on Linux. And now with the promise of .NET Core, with the promise of XPlat, we can run it. We can run like Hadoop.NET on Linux, right? Like completely .NET. Like, so a big win for .NET, big win for all of us .NET C# guys. So, so that's where it really that's what it really boils down to. Oh yeah, so. No, so yeah, this is the roadmap I have. Like, so I just got started. Thanks, Glenn. So I just got started on it. So the bits don't even compile. So I'm just like kicking. Yep. They don't even compile. I'm just getting started on it. Yeah. So so this is the roadmap. So Hadoop uses its own data types. So I'm starting with that one for I/O. So start with that, and then hit HDFS, and then Yarn. And then like get to the other pieces like Zookeeper and all, and then write the extensions for it. So that's the roadmap that I have. So please get in touch with me. I'm here till the end of day today, flying out back tonight. But for those of you who didn't get my contact details, I'm going to put it up on the slide share for the conference. Yeah, I'm going to be in the hack space too this afternoon. Like, I'm going to put a card in there, so I'll be hacking at it, like doing some more work. So if you want to get in touch after lunch or anything, so that's my presentation for today. Thank you.